We will be discussing today on how to easily transform compliance to code using AWS Config, Config Rules, and the Rules Development Kit. We will be taking questions all throughout the webinar, so please feel free to post your questions, and I will also take time to answer questions at the end of the session today. So please continue to keep those questions coming through. As businesses continue to scale and grow their cloud environments, there is an increasing demand for a scalable mechanism that ensures cloud resources are adhering to the specific requirements imposed by their businesses, security teams, internal policies, or their particular regulators or auditors. In this session, we'll learn how to easily transform compliance to code and automate security so businesses can scale effectively and address compliance requirements on AWS. So today, together, all of us together, we will dive deep into AWS Config Service and concepts including managed and custom config rules. We'll learn about behavior-driven development and how we can use it to better define security requirements and develop config rules. I'll introduce the Rules Development Kit for config rules, and we'll use that to build custom config rules using the Rules Development Kit. We'll also together discover best practices on multi-account setup for deploying security controls. So traditionally, security operations or SecOps teams can spend a lot of time manually managing systems compliance information and proving compliance. As SecOps teams are usually highly specialized and small in number, manually managing and proving compliance is not scalable in the cloud. Demonstrating compliance is also traditionally an annual occurrence, which can be quite stressful as teams scurry around for weeks to collect screenshots and produce documents to validate compliance data. Does this at all sound familiar? Well, with continuous compliance, you never have to manually manage spreadsheets or wait for the dreaded audit period. You can have visibility of your compliance levels all of the time. Continuous compliance is the capability of a security operations team to transform compliance to code, deliver security controls consistently across AWS accounts at scale, and make it part of the day-to-day. And we can have complete transparency of what's running in our AWS environments, and we have the ability to audit and report compliance levels at any time on demand. Now, this can significantly free up security operation teams to focus on better defining controls and adopting a DevSecOps model to iteratively develop, test, deploy, and continuously deliver security controls. So let's dive into compliance as code and discuss the AWS services imperative to continuous compliance, AWS Config and Config Rules. We'll start with AWS Config. So AWS Config is a service that enables you to assess, audit, and evaluate the configurations of your AWS resources, and it's available in all regions. Config continuously monitors and records your AWS resource configurations and allows you to automate the evaluation of recorded configurations against desired configurations. With Config, you can review changes in configurations and relationships between AWS resources. You can dive into detailed resource configuration histories and determine your overall compliance against the configuration specified in your internal guidelines. We'll jump into some of the AWS Config concepts now. And so firstly, the AWS Config service has a configuration recorder. And this detects changes in your resource configurations and captures these changes as configuration items. If you set up the AWS Config by using the console or the AWS CLI, AWS Config automatically creates and then starts the configuration recorder for you. By default, the configuration recorder records all supported resources in the region where AWS Config is running. You can also create a customized configuration recorder that records only the resource types that you specify. AWS Config also creates configuration items whenever it detects a change to a resource type that it's recording. So by definition, a configuration item represents a point-in-time view of the various attributes of a supported AWS resource that exists in your account. So for example, if AWS Config is recording Amazon S3 buckets, AWS Config creates a configuration item whenever a bucket is created, updated, or deleted. AWS Config currently supports 22 services and over 60 resource types. And these numbers are continually growing, so keep an eye out on that. We'll delve into the different components of a configuration item and their importance a bit later in the session. But for now, we'll continue on. As AWS Config continually records the changes that occur to your AWS resources, it sends notifications and updated configuration states through the AWS Config delivery channel to the Amazon S3 bucket that you specified when you configured your delivery channel. You can change the settings of your delivery channel. The settings that you can modify are the Amazon S3 bucket, to which AWS Config sends configuration snapshots and configuration history files. You can specify how often AWS Config delivers configuration snapshots to your Amazon S3 bucket. And then lastly, the Amazon SNS topic, to which AWS Config sends notifications about configuration changes. So all of those three you can specify in your delivery channel. It's actually also worth calling out that if you can actually only have one delivery channel per region, per AWS account, and configuring the delivery channel is a must to use the AWS Config service. Now, what the delivery channel delivers to S3 buckets are known as configuration snapshots. A configuration snapshot is a collection of configuration items for the supported resources that exist in your account. And these configuration snapshots, it's a complete picture of the resources that are being recorded and their configurations. The configuration snapshot can actually be really a useful tool for validating your configuration settings in your AWS account. So all the concepts that I've highlighted in this flow diagram allow you to review changes in configurations and relationships between AWS resources straight out of the box. You can dive into detailed resource configuration histories and determine your overall compliance against the configuration specified in your internal guidelines. All of this significantly simplifies compliance auditing, security analysis, change management, and operational troubleshooting without you having to do much at all, but just enabling the AWS Config service. Let's discuss another important feature of the AWS Config service, Config Rules. Config Rules give you the ability to define your compliance requirements in AWS as code, giving you software-defined continuous compliance. With Config Rules, you can verify that existing and newly launched AWS resources conform to your organization's security guidelines and best practices. No more wasted time manually inspecting cloud resources. How useful is that? While AWS Config continuously tracks the configuration changes that occur amongst your resources, it also continually evaluates your resources as they're created, changed, or deleted, and checks whether these changes violate any of the conditions that you've defined in one of your config rules. If a resource violates a rule, AWS Config flags the resource as non-compliant and sends a notification via AWS Simple Notification Service or SNS. AWS Config provides customizable predefined rules called managed rules to help get you started. You can also create your own custom config rules, which represent your ideal configuration settings based on your specific requirements imposed by a business, internal policies, or particular auditors. We'll dive deep into designing and building a custom config rule later in this session, so stay tuned. We'll look a bit more into the components of a configuration item, which, if you remember, is a point-in-time view of the various attributes of a supported AWS resource that exist in your account. The 5 components of a configuration item include metadata, which is information about this configuration item, such as at the time when the resource item was captured. Secondly, the attributes of the resource, such as resource IDs and tags. Any relationships which can describe how the resource is related to other resources associated with the account. Any related events. And lastly, the current configurations, which is the information that's returned through a call such as describe or list API of the resource. So the current configurations of a specific resource. A thing to note is that it's all in JSON. So if you're interested in a specific part of the configuration, you can extract that out. So for example, if you want to know the tag for this specific volume, you'd be able to extract the tag section of the configuration in the configuration item. Cool. So now that we know in detail what configuration items are, let's dive into how custom config rules work. As I mentioned earlier, custom config rules are rules you develop to represent your ideal configuration settings in your AWS account. You associate each custom rule with an AWS Lambda function. If you're not familiar with AWS Lambda lets you run code without provisioning or managing servers. You pay only for the compute time that you consume. So there's no charge for when your code is not running. The code you run on AWS Lambda is called a Lambda function. For our case, our config rule Lambda function will contain the logic that evaluates whether your AWS resources comply with the rule. Each rule, when triggered, calls a Lambda function. There can only be one Lambda function per custom rule. When the trigger for a rule occurs, AWS Config invokes the rule's AWS Lambda function by publishing an event. This invoking event contains information such as configuration item information and any rule parameters. Then AWS Lambda executes the function by passing the event to the function's handler. The Lambda function has a logic you codified to verify a configuration, verify that a configuration comply with the expectation. So in this logic, you can also read any additional metadata of the configuration item that you need, so such as a describe call. And then once the Lambda processes this logic and derives the compliance result, it returns this result back to the AWS config servers via the put evaluations API call, which is then displayed on the AWS config console for the resource being evaluated as compliant or non-compliant. So this, in essence, is how the AWS config service and the custom config rules work. One other thing to note is that the trigger for a custom config rule can actually be of two kinds: configuration change or a periodic trigger. This is essentially the trigger that kicks off the evaluation process for your custom config rule. With configuration change triggers, AWS Config runs evaluations for the rule when certain types of resources are created, changed, or deleted. With periodic triggers, AWS Config runs evaluations for the rule at a frequency that you choose, for example, every 24 hours. You can choose to have a rule triggering for configuration changes and periodically. If you do choose both, AWS Config invokes your Lambda function when it detects a configuration change and also at the frequency that you specify. As I mentioned earlier, when the trigger for a rule occurs, AWS Config invokes the rule's AWS Lambda function by publishing an event. This invoking event is what you see here. It contains information such as configuration item information and any rule parameters. Then AWS Lambda executes the function by passing the event to the function's handler. The main difference between configuration change trigger and periodic trigger is that the change trigger invoking event is that in the change trigger invoking event, the configuration item information will be present. But in the periodic time-based triggers, there is actually no configuration item information in the invoking event. And this is quite important when we start to build our own custom config rules. And we'll delve into that later in this session. Before we jump into designing and building config rules, it's best to give a bit of guidance on which trigger types to choose for your custom config rule. If AWS Config is tracking the resource, it's best and easiest to choose the configuration change trigger. If you recall, AWS Config supports 22 services. However, AWS actually has a lot more than 22 services, yeah? So for those services that AWS Config doesn't support, you can use a periodic trigger. In some use cases, you may want to use both periodic trigger and a change trigger. You can use both triggers, but just note that this will make your rule logic quite complex. So it's usually, to keep it simple, it's best to stick with either the configuration change trigger or the periodic trigger. So let's dive into best practices on how to design a config rule. So first we'll start by designing a config rule, and then we'll dive right into building our own custom config rule. So security teams and businesses can define the compliance and security requirements as technical scenarios in a Gherkin-like documentation. Now this is very handy because this can form a standardized descriptive mechanism for compliance rules that are human readable and behavior driven. Using Gherkin-like documentation, different security teams can have a common platform to define the security requirements without having to look at the developed code for the logic at all. However, developers can actually use the same document to develop associated test cases. This can form the basis for behavior and test-driven security, which is imperative in a modern day security operations team. Gherkin documentations usually have a feature statement to define the user story for the config rule, followed by scenarios that outline every permutation that needs to be tested, given any preconditions and outlining an outcome. Each of the scenarios can then form a specific test case. Let's go through some basis of writing test cases. When writing test cases from each of the Gherkin scenarios, it's best to follow these guidelines. Aim to cover all permutations of inputs in your Gherkin scenarios and associated test cases. You will have edge cases, and it may be a bit of an overkill to cover all of the edge cases, but for those ones, just make comments on the edge cases and why each of those weren't covered. Secondly, keep distinct coverage on the test cases. Thirdly, know that if you find bugs, humans will need to fix it, well, at least initially anyway. So comment wherever needed to make it human readable. And lastly, use a reasoning approach wherever you can. Okay, let's put everything we've learned into practice using a common example that many of us using AWS would come across. Ensuring that every IAM user in our AWS account has multi-factor authentication enabled. Now, how do we break that down into a Gherkin-like document? So firstly, we have a feature that outlines the user story. To enforce strong authentication, as a security officer, I want to ensure that all IAM users have MFA, except those users that are whitelisted. That is, any users that we put into the parameter will be in a whitelist because no MFA is required for those IAM users. And then here we have defined 5 scenarios. And this may not cover every single scenario, but this essentially is an example to form the foundation or the basis of the Gherkin-like documentation that will drive the test cases. First one, if the whitelist parameter list is configured and the IAM user ID under evaluation is in the whitelisted user list, then the evaluation is compliant as no MFA is required. So if you notice, the first few handle the situation where there is a whitelisted user list parameter configured. Second scenario, if the whitelisted parameter list is configured and the IAM user ID under evaluation is not in the whitelisted user list, but the user does have an MFA attached, then the evaluation is compliant as the user has an MFA. The third one, if the whitelisted parameter list is configured and the IAM user ID under evaluation is not in the whitelisted user list, and the user doesn't have an MFA attached, then the evaluation will return non-compliant as the user has no MFA. The last 2 scenarios handle the situations where there is no whitelist configured. So if the whitelist parameter is not configured, this is number 4, but the user does have an MFA attached, then the evaluation is compliant as the user has an MFA. And lastly, if the whitelist parameter list is not configured and the user does not have an MFA attached, then the evaluation is non-compliant as the user has no MFA. Right. Now that we have the Gherkin-like scenarios defined, let's dive into the code and start to build our custom config rule. But before we jump into coding, I'd like to introduce you to the Rules Development Kit, or RDK. RDK is an open source software developed by an AWS cloud architect, and you can find it on GitHub. It is the fastest way to get started writing custom config rules and the easiest way to develop, test, and collaborate on rules going forward. It's a CLI that wraps AWS's APIs in an easy-to-use high-level command. It uses Boto, and Boto is the AWS SDK for Python, which allows Python developers to write software that make it quite easy to use services such as S3 and EC2 in the applications that you write. Boto also provides an easy to use object-oriented API as well as low-level direct service access. So the RDK uses this, and the RDK also provides a certain level of fault tolerance and scaffolding without being too opinionated on how to write rules, what rules to write, and how to structure accounts, networks, or security framework. But the biggest benefit that the RDK provides is a natural developer-centric workflow. Just a point to note is that the rules development kit is in version 2, so it's an open beta. So please feel free to start testing it out, start collaborating on it, and please feel free to give us feedback on it as well. As I just mentioned, the RDK promotes a natural development workflow. So as you can see here, as soon as you set up the developer environment, you can use the RDK to iteratively write the tests from the Gherkin-like scenarios that we just saw, write the code, do unit testing using the RDK, deploy in a test account using the RDK, debug, and continue changing and iterating on the code. All of this can be done using the RDK, making your config rule development a seamless workflow. So naturally, today we will be using the RDK to build our config rule, but before we start coding, it's a good idea to make some decisions on the goal we wish to achieve, the scope and trigger, and any parameters we wish to highlight, and which resource types we want to report evaluations on. Right, this is just good practice to get all of these down before you start coding. And it's worth noting that your evaluation results can actually be of 3 types: non-compliant, compliant, or not applicable. For our purposes, and our example of MFA on an IAM user, we've already defined our goals in the Gherkin-like documentation in the user story section, if you remember, in the features section. And the rest we've actually identified here. So we're using a change trigger on AWS IAM user resource type. We'll have an optional parameter whitelisted user list, and evaluations will be done on AWS IAM user. Perfect. So let's begin coding. So I've got my terminal window open here to access RDK CLI. I'm just going to show you how to use the RDK to begin with. So to initialize RDK, I'll run RDK init. As you can see, a few things happen. It checks the configuration recorder, which one to use, the IAM role to use for the config service, whether the service is on, etc. I'm going to create our rule here. So typing the RDK create followed by the rule name, as well as the resource types to use. And you can see here it's created 3 files. A test.py file, a py file, and a parameters.json file. The parameters.json file has all the foundational info that we've defined earlier as resource types and the parameter list. The rule, or your rule, or our rule today, will go into the .py file. You can see that you're using Boto 3. The py file actually leaves the space where your rule logic will go in the commented out section, and then handles all of the undifferentiated heavy lifting, such as extracting config service events, building body of the evaluation, and converting API configurations, and then most importantly, I'll just scroll down here a little bit so you can see, putting the evaluations results and the results token back to the AWS config service. So all of this is just handled as the scaffolding. The last file is the test.py file, which uses the unit test.mock testing library for Python. As you can see, it has examples of how to form test cases, as well as scaffolding for building dummy invoking events for both change configuration and periodic triggers. The last thing to note, so I'll get out of this, and one thing I'll show you is that you can actually get sample configuration item data from the RDK by typing RDK sample CI. So for our case, we'll type in AWS IAM user, and you can see here that it has the configuration item information, such as a mock user ID and any policies that it has on the IAM user. So you can actually use this to create test cases, mock test cases for your unit testing. So let's dive into writing test cases, and this is where test-driven security comes in. So we'll start off by deriving unit tests from the Gherkin scenarios that we've developed, and then once we have our testing developed, we'll go into writing the code. As I mentioned earlier, the RDK uses unit test mock unit testing, which is a library for testing in Python. It allows you to replace parts of your system under test with mock objects and make assertions about how they have been used. Unit test.mock provides a core mock class, removing the need to create a host of stubs throughout your test suite. After performing an action, you can actually make assertions about which methods and attributes were used and arguments that were called with. You can also specify return values and set needed attributes in the normal way that you would. Additionally, mock actually provides a patch decorator that handles patching module and class level attributes within the scope of a test, along with Sentinel for creating unique objects. So this is essentially the mock testing file that we'll go through here. So first is creating a mock for the IAM client for AWS. The couple of things to highlight here is that we do have to call out the message type, whether it's a configuration item change notification or it's a schedule notification. So based on a configuration item change trigger or a periodic trigger. For our purposes, it's a configuration item change notification. And then if you can see here, we've built out essentially in the invoking event, the configuration item. So putting in the information and that you can use from the sample CI that I've shown you earlier. And then we go into building out each of the test cases based on the Gherkin-like scenarios. So the first one that I've highlighted here is essentially building out the the class of the first test. And you can go through this in your own time, but essentially I just wanted to call out that each of these scenarios, the test cases have been based on the scenarios that we've built on the Gherkin. The thing to highlight is that we do have to construct the MFA device in our mock unit testing because none of this information will be coming through in the mock test. So we'll have to essentially mock all of these out. And then here we have the last two scenarios as well, where there was no parameter whitelist, and essentially it handles the compliance and non-compliance results within the test cases. So please feel free to go through this in your own time. The slides will actually be provided after this session. So now that we have our rules, our test cases defined, we're going to jump straight into writing the rule. So writing the rule for this is actually quite simple. And if you remember, we will be writing the rule in the logic section of the PI file in each of the 3 files that we got from the RDK. Essentially, all I'm doing here is I'm actually getting the resource information from the configuration item, which should come through in the invoking event for this rule. And I'm just calling it out here that if a whitelisted user list is there in the valid rule parameters, and we've defined valid rule parameters further down. If the whitelisted user list is there, then essentially we go through the whitelisted user list and they will just be handled as compliant. And then if we go further down, if an MFA device has been detected and the the user ID is not in the whitelisted user list, so I'll continue. Let me just go back a little bit. Then you can see it's actually non-compliant. Okay, so if they're not in the whitelisted user list and they have no MFA present as defined here, then they're not compliant. If they have an MFA device present, as you can see here, then it is compliant. And the next section essentially is validating the parameter. So all we're just checking here is, if you notice, AWS user IDs all actually start with AIDA. So we've just called it out. If it doesn't start with AIDA, then we're going to raise an error. If the user ID is actually in not alphanumeric, then we're going to raise an error. Essentially, that's us validating our parameter. Perfect. So that's essentially building the body of the test and the rule. Please feel free to go through this at your own time. But why don't we go ahead and actually deploy our config rules. So as you can see here, I'm on the config rules dashboard. This account is not doing so well because there are lots of non-compliant resources. Essentially, this is the config rules landing page on the AWS console. So I'm going to go ahead now and use the RDK to locally run my unit test. So RDK test local and the name of my rule. And essentially, thankfully, all the test cases passed with no errors or failures. So that's very good. I am going to now deploy. So that using the RDK, I can also deploy my config rule. And as you can see here, it's actually using Cloudformation in the backend to deploy in my test environment. So I'm just going to wait here for my Cloudformation operation to finish. But if I do go into my Cloudformation console, I can see that it's actually in progress. It's created a config rule, it's created the Lambda, it's created the Lambda role. So it's actually, the RDK is handling a lot of foundational resource creations for your config rule as well. So let's just see what the evaluation result is. For my rule, I can see that it's picked up a lot of the IAM users in my account. This specific one is actually also non-compliant, test user with no MFA device detected. So I'm actually going to be picking up this user and finding out this user's user ID, and maybe we can put it in the parameter list, and we'll exclude it essentially from our evaluation by it being in the exception list. So let me just do a AWS CLI command and list the users in my account. And I can see the test user here, and this is the user ID. So I'm going to take this user ID for this user. I'm just going to modify the config rule and put this user ID in the parameter whitelist. Let's find our rule again, and we'll actually reevaluate the config rule. So in the config rule console, you can actually go down and click reevaluate, which will essentially trigger your rule to reevaluate. So if you're impatient like me, you'll continue to refresh. If we refresh again. Yep, so we can see now the test user is actually compliant, even though there is no MFA for this user. This user is actually whitelisted. Perfect. So we've gone through the scenario of unit testing and deploying our custom config rule. Now let's actually come to the scenario of how to handle deploying across multiple accounts. Now, most of us in our organization don't just use the one account. We have multiple accounts, such as security accounts, shared services accounts, and obviously security needs to span across all of the different accounts in our environment. So what's the best setup for multi-account deployments? The best thing to note is actually segregated accounts for security operations and security operations applications. As you can see here, I've got a separate account known as the security operations publisher account, or essentially the central security operation account. And this account is where all of my config rule lambdas are housed. Right. The isolation of the config rule lambdas ensures that we have a tamper-proof environment where only security operations teams have the necessary access to deploy or make changes on the code for the config rule. One thing to note is that there is only one Lambda function per config rule. Yeah. Okay. And as you can see, there are sort of application accounts, and in those application accounts we have the config rules for which are associated to each of those Lambda functions. So essentially I've decoupled my config rules and my Lambda functions. I've put my Lambda functions in a tamper-proof security operations account, and all the config rules, as you saw previously in the config rule console, are essentially sitting at each of the individual application accounts. The Lambda config rule, all the config rule lambdas essentially have a Lambda role. And in the application accounts, within the application accounts, the AWS config service has its AWS config service role. There is only one Lambda IAM role. This is the role for all the Lambda functions in the security operations account, as I've mentioned earlier. Now, these are the IAM roles that will require to have the appropriate permissions to allow for cross-account Lambda invocations. So let's run through an example of the mechanics. If config rule X is triggered, the config service invokes the rules associated Lambda function from the security operations publisher account via Lambda permissions. The Lambda IAM role from the publisher account assumes the config service role in the application account to access the AWS resources in the account and runs the evaluation logic in the Lambda function for the config rule. The Lambda role then puts the evaluation results back to the AWS config service. Let's have a look to see what the permissions need to be for the AWS config service role, which the Lambda role will assume. So permissions actually include list and describe resources, along with S3 put objects, so you can actually put evaluation information back into S3 bucket that you specify, SNS public, so you can actually notify you when evaluation results change, config put, again, to put the evaluations back to the config service, config get, config list, and config describe. Essentially, this is a very long down version of what it needs to look like to allow for cross-account role assumption and cross-account deployments. For scale config rule deployment across multiple accounts, Cloudformation Stacksets is accessing the one master account to multiple accounts in your